Hello, welcome back. Sorry for the short interruption. Let's get on with learning to write this code. I'll finish it very soon. So we left it at line 111. So I'll continue from there on. So the next is ESP6. So the next will be ESP7 for the update key. So for that, you can copy the field which I copied from here, field 1, but we have to go to ThinkSpeak to get the right API key and paste it here, which I will show you after I finish typing all the code. So that is what I typed here. Then after you get that, the next step is to print the command for this with the data. So I'll copy this and use it here, and this will be the command 7, and then you need to give the data string because we're going to get the data from the ADC. So I'll copy this again, another printf, and this will be data string. So data underscore string. That data string will come from basic from here, the data string of 8 data. So we're going to use that to here. Okay, so then the next step is to get this line tab in. So I'll get this line tab, and then for that line tab it is the ninth step. As you can see, it's a command 9, so we got to do 9, ESP9. So just simply copy this printf statement and then paste it here and change this to 9, and then give a delay, copy a delay. We have to write the delay program as well, which I will do after this. Give a delay of 1000, just random. Then the last step in here is you got to copy the AIP close. So you got to do the ESP10. So I'll just copy this AT command to close. Whatever in double slash, it's just for our learning, so that you know when you type, that step is for that line, so you won't get confused. So I'll copy this and paste it. So this is for the ESP10 command, and then I'll just give a delay after that. Delay of millisecond, this time just a little bit higher, 5000. Okay, so we did all the commands, and now let's write a delay command. We did so now let's write the function for the next step, which is this void init. Sorry, something is loading up on the background. I'll just wait. Okay, now we got to write the this program. So I'll just copy this function. After this, we're going to write this. So copy that. In this, you're going to call the delay with the first delay millisecond of 5000. Then get the basic commands. Sorry, for some reason there is something loading on the background, so it's causing. Okay. Basic commands. We had to get the basic commands and also call the other function, which is the Wi-Fi connect commands, which is Wi-Fi connection commands. This is just to link with your ESP8266 board. So I'll just go here and double check with the function name. It's Wi-Fi caps con single in commands. Okay, Wi-Fi caps con is single in commands. Okay, and then basic commands. Okay, that's okay. Yeah. Okay, so this step is done, so I'll just simply save it. So now we're going to use the real-time ADC value. So you would see that in ThinkSpeak. So for that, you have to convert the values that you're going to get into an integer value so you can read. So for that, you got to write this function, which you already learned in your ADC command, ADC program. That's what I'm going to do again. So nothing new, it's all you already learned. So I'll be just fast and quick. And so the first is you need to declare the string of 0. The first string, what you're going to capture is value by 1000, and then you ending with converting the first value of 1. Then you got to call the value val equals val of 1000. 1000. Okay, so I'll just copy this, and we got to change few things. So copy. So this is for string 1, this will be 100, and this will be 100. Then you got to do it for just string 2. Just string 2. I'm going to do it for 10, val of 10. Yeah, and then you need to do for string 3 is string 3, and this will be the ampersand to convert. And then the string 4, you got to have it as null character. String 4 null. Okay, so we converted that. So I'll save. I'll move this. Okay, so the next step is we'll write the delay function. You got to write delay, come here all the way down. After this, int of delay, start with variable declaration of int I, then just use a simple for loop of delay greater than 0, and then delay decrement. And then in that, call the iteration I less than 3195, then I plus plus. Okay, so that's it. This delay, this for loop closed, and okay, this is just a simple delay. Now we'll write the program for UART read and UART write, and UART init. I'll copy everything from the UART program here, which we're going to use. It will be pretty much this UART write, UART read, and the UART write, but I'll type it here so that you won't get confused. Okay, so we're going here. Now we need to do the UART integration in the program. Just checking character UART1. Okay, so UART1 read with this should be, I have to pass char value. Yeah, so char. So the UART1 read will be, what are you going to read with? The transmit and the receive pin. So you have to use a simple while waiting for the RxNE bit. UART1 checking with status register, and just undoing that with 0 cross 0 0. I'm going a bit faster here because we have learned all of this in the previous UART module. So if you have any doubt, please do go back and refresh yourself, so you will be more familiar. Then return of the data register. Okay, so that's the UART read. Then you have to write the next function, that's the UART write. UART write of data, come all the way, UART1 character data. So for the UART write, you got to wait for the TXE bit while of UART1. You need to check with the status register, and I'm going to check with the value 80 and wait until it gets cleared, then return with data. UART1 with the data register, and you just simply and with 0 cross FF. Okay, so that's our usert right. Now we'll go and write the usert init. We got to write for usert init program 12C usert init. Okay. Yeah, the usert init first, we're going to use GPIOB and usert1. So first we got to enable that, but I'm going to copy from the previous program, so just to save time, because we already learned this, I'll explain what I have written. Yeah, so first you got to enable the clock access, enable the clock access for GPIO-A and GPIO-B. So to do that, you got to connect the GPIO-B, that's where the ADC is connected to, and then the usert1. You got to enable the clock access and then set alternate function for PB6 to TX and PB7 as RX. So if you go there and if you check on this, then you will be finding all of this GPIO-B, setting up all the registers, and this time we're going to communicate with the ESP8266 and its baud rate is 5200, and if you calculate that, this is the value you get, 008B. So that's what I have written here. And the next step is to, because we're going to use the printf function for the ESP integration, so we can use putchar as well. So I just copied from the previous usert program. So I need to get init IO put character of char C, and this should be usert right, usert 1 underscore right of character, yeah, and then return character. Okay, yeah, that's that. So now we'll get into the main program and we'll call all the functions. So for the main, first step, we're going to call the character data that we used, character data. Then you got to declare the integer of ADC as data underscore ADC. I'm just checking what we given in the ADC, just one sec. ADC init, ADC read, ADC, okay, ADC1, okay, should be fine. And data ADC, I'm just checking once again, just bear with me. ADC1, string, and then here, okay. Then the next step here is we're going to call the usert initialization, initialization. So you have to call the usert init1, I'll just copy the function name, copy that, and then you got to call the ADC init as well, all the initialization codes, ADC init, copy the function name, go to the main program, and you just paste it. Then after that you have to get the ESP8266 initialization. For that, copy the init ESP8266. I'll copy the full function. I'll change it here with here you don't need to put the argument when you call. Then you have to get Wi-Fi account and password. So Wi-Fi account and password. To call that, we have used Wi-Fi account, which is this Wi-Fi account. So you got to call this function. Control-C. So when you call inside the main program, you don't have to specify any arguments, so just call the function name. So Wi-Fi account. Then after this, you need to give the ThingSpeak command. After this, you have to give the IoT cloud command, ThingSpeak commands. So that you need to call the start command, which is I have to get this start. See in this start, yeah, you can also copy from here and paste it here with the semicolon. And remember now arguments when you call the function routine. Okay, after ThingSpeak command, then just give a delay at this stage of 500, and after this you can give a data ADC value, as 30 for a start, so you will see the graph change. And the next step is you have to call the integer to ASCII function. So let's go and call this integer to ASCII. Control-C and paste it. Well, for the integration here, you got to use the data ADC, which we just created as the argument, and the data string you got to combine both. Okay, after you done that, then now is the time to collect the data commands. First off will be data underscore commands call, which is I just typed. We have to go here and get the data underscore commands, and after you call that, give a delay as well, delay of millisecond of 500. Then you need to link that to the ADC, the PA equals ADC read value of. So whatever data you control, that has to be read with that variable data. Data commands, delay of 500, then then you got to, because you're going to convey that to the IoT cloud. So after you give the data command And before reading the data value, you have to start again with the ThingSpeak command. Data commands 500, then ThingSpeak start, then just checking ADC read data commands. Wi-Fi account, ThingSpeak delay data ADC, then integer to ASCII data commands of 500, then ThingSpeak, then now we're giving radio. And also you can check for different value if you want to. Just I'll put as data ADC value, say next you're sending 90 for instance, then you got to get that to read. So again you have to go to integer to ASCII call. So copy this integer to ASCII again, call this, okay, and then string, and then you got to get the data commands again with the delay data commands. Come here and paste it. Yeah, something is loading, sorry, bear with me. Okay, and then finally we're going to finish with a simple printf to end. Printf okay, we finished the program, so just save it and then right click and do the build. Right click on the project name and do a build just to check for any errors. So build project. Sorry, I'm just waiting for right click, build the project, and as you can see this is building and checking in the background. 19% gone, so we have to wait until it checks the whole thing. Okay, we got 3 errors. I'll check what the errors are. Character data. Okay, character of data, and then user type definition. Oh, sorry, lowercase, my bad. It's status register, which is easy fix. Then okay, status register and 2. Just checking in case if I missed out on anything, just give me a sec. ADC read would be SR and 2. Okay, so now save it, and 1, 2, and then this will be the error. Total clear. Okay, build again. gone for 22%, which is good. Okay. Unused variable data. Okay, I got to check that warning. Just one sec. Three errors and 2 warnings. Sorry, commands, my type. Commands. Basic commands. Because I used basic underscore commands and I mistyped it there. Basic commands. And we also called here basic user1. This character data is not used, it's character data. Data ADC unsigned into character data. We don't need this character data. Save it and then right click, do another build. Data. User1 char data. Okay, it's happy now and it's all 0 errors, 0 warnings, which is really good. I have connected the hardware, and so now let's go and check the ADC for a start. So right click, I will debug the program, debug as, debug configuration, make sure you are running on the same program. Browse for it, so we are going to use IoT and then browse and take it to the USAT here, which will be on the desktop. It will be in target. .elf. Okay. .elf. Okay. So then go to debugger. You got to enable serial wire viewer. That's enabled. ST-Link is enabled. Just make sure they are enabled. Yeah. And then apply. And then debug. This will change from build perspective, C++ perspective to debug. We had to wait for this to change over to 100%, then we can check the ADC value. Final sequence launch. Okay, I'll give you a short break, but before that I will get the ThinkSpeak, and then I'll give you a short break. Once you come back, I'll show you the demo of it. Yeah. So in a browser, just open thingspeak.com. I already have an account with ThinkSpeak. So I'm just logging into my account. Sign in. If not, you got to create your login for ThinkSpeak. This is where you're going to see the data. So it's still loading. Sorry. ThinkSpeak. Sign in. I'm just checking. Sign in. Okay, I'll give you a short break, so please go and enjoy the break. When you come back, I will show the demo and finish it off. Okay, I'll catch you back shortly.